morning everyone. My name is Kapil and my USN is 103. So my topic is insertion sort. So basically insertion sort is a sorting technique in which we take each element and put it at its correct position each at a time. So I will give you the basic idea how the simulation is done, and then we will build the algorithm from the simulation only. So the array I have taken is 5, 4, 10, 1, 6, 2. So we will start at the 0th index and divide the array into two parts, that is sorted list and unsorted list. So 5 is part of sorted list and 4, 10, 1, 6, 2 are part of unsorted list. So we will take the first element of the unsorted list every time. So this time 4 is the first element of unsorted list. 4 will be compared with the elements of sorted list until it is greater than the element of sorted list. When it is greater, we will stop at that time and put it at the position. So 4. So sorted list has only one element, which is 5. So 4 is less than 5. So 4 should be before 5. So we will swap 4 and 5. So these two now become part of sorted list, and this is unsorted list. 4 and 5 are sorted list, and 10, 1, 6, 2 is unsorted list. So that I told you, first element of unsorted list, that is this time 10. We'll compare left side, like we'll compare 10 with 5, then 4, not from the beginning, from this side to the starting. So 10 is less than 5? No. So 10. So we will not compare after 5 because it is a sorted list. So 4 is already less than 5. So it will be already less than 10. So 4, 5, 10, 1, 6, 2. So now this part has become sorted list 4, 5, 10, and 1, 6, 2 has become unsorted list. Okay. Again we will take the first element of unsorted list, compare with all the elements of sorted list from this 10, 5, 4 like that. So 1 will be compared with 10. 1 is less than 10, so we will swap. So yeah, then we will go to next comparison in sorted list. 1 is less than 5, yes. 1 is less than 4, yes. So its position should be before 1. So we will shift all the elements by one position. So first 1, 4, 5, 10, 6, 2. So now 1 has also become part of sorted list. This is the sorted list and this is the unsorted list. Again we will take the first element of sorted list, that is 6, and we compare from this side. 6 will be compared with 10. 6 will be compared with 5. 6 is greater than 5, so we will stop at that position. So after 5, 6 should come. 1, 4, 5, 6, 10, 2. Now this is the sorted list and this is the unsorted list. So only one element is left, so we will choose 2 and compare with all the elements this way. So 2 is compared with 10. Yes, it is less than 10. 2 is compared with 6. Yes, it is less than 6. 2 is compared with 5. Yes, it is less than 5. 2 is compared with 4. Yep, it is less than 4. Now 2 is compared with 1. No, it is not. It is greater than 1. So we will stop at 4, and 2 should come after 1. So we will shift all these elements by one position. And finally 1, 2, 4, 5, 6, 10. This all become part of sorting list. and you can see the array is sorted. Now the simulation is done. Now we will design the algorithm from this. Now we will write the algorithm from the simulation. So number of elements are 1, 2, 3, 4, 5, 6. N is equal to 6. And we have done number of iterations 1, 2, 3, 4, 5. Number of iterations are 5. So we will make a for loop I equal to 1 to I less than n and I plus plus. So it will do n minus 1. If n is 6, it will do n minus 1 iterations. Now, every time we are choosing the first element of unsorted list. So we will make it as key element. Where that key element is the position we are finding for that element. So 4, then 10, then 1. So we can see that every time it is increasing by 1 and it's starting from first index. So key element A of I, as I is also starting from 1. Okay. Then we are comparing from this side. So if we take 4, that is first index, we are comparing with 0. If we take second index, we are comparing with 1 and 0. If we take third index, we are comparing with previous all the indexes backward. So we will take an integer j that is containing I minus 1. That is, if it I is this, it will go there. I is this, it will go there. I is this, it will go there. So we are comparing till when? We are comparing till when? Until unless it is j becomes 0, that at the end it reaches the end, or the element, key element becomes greater than the element previously. So while j is greater than equal to 0 and A of j, so while key value is less than the jth value, jth index array, so we will swap till then. For example, this one, 1 is less than 10, yeah, we will swap. 1 is less than 5, swap. 1 is 4 less than 4, swap. We will swap it. We are moving each every index by one position. While this condition is satisfied, while key value is less than the previous all the indexes value one by one, going left. So A of j plus 1 equal to A of j. Okay, we are moving one position each time, and after each iteration we are decrementing j by 1, because we have compared with 10, next position should be 5, so we are decrementing j. So like that it will compare. And finally, like one will come to the position where it has no indexes, j is less than or equal to 0, or if it is cancelled at that time, so j value will be already less than the original index value. So we have to add 1 and put it at assign key to it. And for example, like this 2 is ith value is, this is 5, I 5, j should be 4. So while j is greater than 0 and key value is less than ij. So key value is 2 is less than 10, yes, so we are moving 10 this side, and moving 10 is this side, and putting 2, not moving 10 this side. Then 2 is compared with 6. Is key value less than 6? Yes. We are moving 6 this side by one position. So 10, 6 has come. Then 2 is compared with 5. Yeah, we are moving 5 by one position. 2 is compared with 4. Yes. Then 2 is compared with 1. No. So at this time, gh value is 0 when it is compared with 1. So we can see second value it should be at first index, that is 0 plus 1 should be equal to key value. So this is insertion sort, and for time complexity, best case we can see if the array is already sorted, it will never enter this while loop if it is already sorted. So best case is O of n, that is the number of iterations that will happen in an average. Average case, that is like this one, jumbled one. So on an average it is iterating n minus 1 times, and this will on an average it is iterating n minus 2 or n minus 1 times. So if I multiply, the major terms will be n square, so it will be O of n square. And worst case, that is all the elements are in descending order. So all the elements are in like descending order, so we have to put all from starting to first initially. So on average it will work n minus 1 times, and it will run every time. So it will also work n minus 1 times, so n minus 1 square. So major term is n square. So worst case also n square. This is done.